graduate level pure mathematics textbook, every section comprises of definitions, examples and results. Now, how to read or write proofs. So that is the main content of this video. A proof is to be written or read keeping in mind the GPTC rule, where G stands for what is given, P stands for what is to be proved, and T stands for the technique involved in proving the result, and finally the conclusion. A theorem or a lemma result can be proved using various techniques. So the techniques of proving are direct proof, proof by mathematical induction, proof by contraposition, proof by contradiction, and proof by construction. Now, direct proof. In direct proof, the conclusion is established logically combining the axioms, definitions, and earlier theorems. Proof by mathematical induction. Suppose P of n is a statement over the natural numbers. If we are using first principle of mathematical induction, then we have to check whether P of n is true for n equal to 0, and the truth of P of n for n equal to k implies the truth of P of n for n equal to k plus 1. Then P of n is true for all n. Supposing the second principle of mathematical induction is to be used, then check if P of n is true for n equal to 0, and check whether the truth of P of n for n less than k implies the truth of P of n for n equal to k. Then P of n will be true for all n. Now, in the case of proof by contraposition, suppose you have to establish that P implies Q. Then prove that not Q implies not P. Then proof by contradiction, assume the contrary and using the logical reasoning arrive at a contradiction. Now, proof by construction, establish the existence of a mathematical object by creating or providing a method for creating the object. Now, how to prove equality or uniqueness. Now, suppose we are given two sets. If you want to show that those two sets are equal, then we have to prove that A is a subset of B and B is a subset of A. Suppose we have A and B to be finite sets. In order to show them A and B are equal, we have to check whether both of them are of the same order, that is, they consist of same number of elements, and either we have A is contained in B or B is contained in A. Now, in the case of two mappings, we say that two mappings F and G to be equal if the domain and the codomain of both the mappings are the same. That is, we need to have F to be a mapping from the set S to T, then G should also be a mapping from the set S to T. So we need to have the domain and the codomain of both the mappings to be the same, and they should agree on all the elements of the domain, meaning that f of x should be equal to g of x for every x belonging to the domain of f and g, namely S. So now in the case of two numbers m and n, suppose we want to show that two numbers m and n are equal, then we can establish that m is less than or equal to n and n is less than or equal to m. Supposing we have m and n to be positive integers, to prove the equality between them, it is enough to show that m divides n and n divides m. Now, in the case of algebraic structures, we have uniqueness of two algebraic structures by establishing an isomorphic relation between the two algebraic structures. Now, in the case of a function, sometimes it is written, it is obviously onto. So when should we write a sigma from a set S to T to be obviously onto? When we have S sigma is equal to T. That is, the range of sigma is the whole of the codomain. Now, finally, after writing the proof, you have to give a proofreading to ensure that all the reasons for each step are provided. Now, supposing we want to disprove a result, okay, then a counter example is to be given. That is, give an example in which the result